The pulley system. What's a pulley? A pulley is a simple machine that permits the change in direction of forces depending on the masses of the bodies involved. The pulley we're actually talking about here is just a wheel upon which a rope is tied, and to each end of this rope or a string is a mass. Right. So let's have the scenario. Upon the surface at this edge is a pulley, and here lies a mass attached to a string, and on the other end too is the second mass. So if this is your M2 and this is your M1, provided M2 is greater than M1, this becomes more heavier than this, right? And the body accelerates towards this direction. If the reverse is done, if M1 is greater than M2, the body travels in opposite direction, right? So if this is well understood, can we take cases that present insights of questions that you're likely to meet or come across as a student? So case one, provided I have an inclined plane inclined at an angle theta to the horizontal, and upon it is a pulley. On the pulley lies a string, and at the end of each string is a mass. Provided this is our M1, or this is our M1, and this our M2, and provided M2 is greater than M1, what happens to the system? Acceleration of the system, or the system moves in this direction, and that's the acceleration. Notice that we're actually dealing with a frictionless surface. Hence, we're not expecting the coefficient of friction. And if the coefficient of friction is 0, then frictional force does not exist. So, but note that this mass is actually traveling upwards, right? And because it's traveling upwards, it's against gravity. And when the body is projected upwards, what happens to gravity? Gravity becomes negative. And for this mass here, the body is traveling in favor of gravity, hence gravity becomes positive. So what is the interpretation of this on this body? We're going to have the weight bringing this body downwards, or trying to bring the body downwards, would be a negative weight, right? It will be minus m1g sine theta. So it's actually attracted theta because of this angle, because this particular side is inclined at an angle, right? So for this other side here, we don't need the sine theta because the body is on the vertical, purely on the vertical. Hence we have plus g because the gravity is positive, right? So this gives you the weight bringing the objects downwards, right? If that is done, we have the tension in the rope too, right? Notice that the tension in the rope is always tending towards the pulley. You have T. Tension is also a force in newtons. Now, the tension here is the same thing as the tension here because the material is not changing, the rope is not changing. So it's still the same material here that is still holding this mass here. Having been the material here is different, then the tension here will be different from the other one. So as a student, you might be asked to find the tension in the system, in this pulley system, or the acceleration. So once you're asked to find that, what do? Use your equation of motion as your Newton's equation of motion. So what are you going to have? This is your net force, right? And if this is your net force, what are you expecting as your net force on each of these sides, on each of the sides? I have, for the side here, how many forces do I have here? I have this force here, I have this force here. So I only have two forces, right? Now, you can think of this mass here. Whenever this is negative, this must be positive, right? So what do I have? I have plus T minus M1G sine theta equals to MA. The whole of this is your net force, right? This is the first equation. So for the next equation, I have the side here, right? So for me to deal with that, I have this to be positive. Once this is positive, what happens to tension? Your tension becomes negative. Does that make sense? So what am I going to have? I have M2G, or you start with your tension, if you like, C minus T, right? Plus M2G equals to MA. These are my two equations to deal with this particular problem. This will actually lead to simultaneous equation, 1B. So we are having the same example. So it's still the same condition, but in this case, we want to make M1 to be greater than M2. Still a frictionless surface. So I have my tension. Always remember, because you're using a rope, you must have a tension tending towards the pulley. So the two tension is right there. And because the M1 is greater than M2, acceleration go opposite wise, right? Hence, the weight bringing this object down would be positive M1G, right? M1G sine theta. It is positive because acceleration due to gravity is positive, since this mass is it's moving in the favor of gravity, right? So, and this is traveling upwards, hence gravity is negative. So you have minus the weight that will be acting on this body would be minus M2G, right? So when this is positive, what happens to tension? Tension becomes negative, and when this is negative, tension here becomes positive, right? So you can be asked to find tension or acceleration. So for this particular side, what will be my forces from equation of motion? So I have F equals to ma, right? So what am I expecting as my net force? My net force will be plus M1G, irrespective of whether you start with the tension or not, it's still the same. So you have minus T equals MA. So this gives you first equation. The second equation, you have T minus M2G, right? Everything to be equals to MA. So these are the two equations to look for either your acceleration or your tension. And why do we think we need two equations? Because the tension in the string is actually homogeneous. It's just one for the two. Do you understand now? Forget the fact that it is positive here and it is negative here, irrespective. And the same thing happens to acceleration. Acceleration is just a single entity. Hence, we need to combine the two, the effect of the two masses or the forces on the two sides together to get either our acceleration or the tension, right? For the next case, we have case 1C. So I have something of this nature, right? There's the pulley here. Let's assume the mass is right here, and the second mass is at the other end of the pulley of the string, right? So if this is your M1 and this is your M2, literally from the diagram, you know M2 is greater than M1 because you can see that the M2 is actually pulling this M1 upwards and itself is coming downwards, right? So what happens to acceleration due to gravity? Gravity will be positive here, while gravity here, because the object is projecting upwards, the gravity will be so negative. Since gravity is negative, the weight bringing this object down will be minus M1G. So for the weight here, it will be plus M2G, right? Now, in that case, note that you have your tension. The tension is always towards the pulley. If this is negative, then the other force, which is tension, will be positive. If this is positive, the other force, which is tension, will be negative. All right. So to solve this question using equation of motion, you still have F equals ma, right? This is your net force, right? If that is the case, what are the forces you have here? It's actually called a net force, hence you have T minus M1G to be equals to ma. So you can be asked to find the acceleration of this body. So the order is M2G minus T, everything to be equals to ma. So you have the second equation. So for the next case, Case 2. So I want to pick an inclined plane having a rough surface now. The coefficient of friction is given, right? And the surface is a rough surface. Hence, it has friction, right? We have a rough surface here. Right. In that case, provided we have a mass here and there is a pulley, upon the pulley is a string holding the other mass connected, right? So what will happen to tension in this? You have tension is tending towards the pulley. So you have tension here, provided we have M2 here and we have M1 here. So we have M2 to be greater than M1, right? Acceleration of the body will be moving downwards. It means for this mass, you have gravity to be negative because it's projecting upwards. So what do I have? The weight of the body will be negative, m1g, and it is also inclined, so you have sine theta, right? For this body here, the body is coming downwards, hence gravity is positive. So the weight bringing the object downwards would be W equals to m2g positive. Now, once this is positive, what happens to this? This becomes negative. Once this is negative, what happens to the tension? It becomes positive. So for this particular question, you would be given the question of friction because the surface is rough. And if you're not given because they have told you that it is a rough surface, then you should know that frictional force is applied. Coefficient of friction would be between this mass and that surface. So I have coefficient of friction here. Does that make sense? Now, as this body travel in this direction, motion is in this direction. Friction will be opposite to motion because friction is that force that opposes motion, right? So in that regard, frictional force on this mass, right, to be around this area here. So what will be the sign of the frictional force? Is negative because it is acting this way, and this tension is acting in the opposite direction. They are vectors and they should be subtracted since they're in different directions, right? So is frictional force applied here? No, because the mass is not with any surface. Does that make sense? Calculate for the acceleration or the tension, or sometimes they might ask you the question of friction and the like. So I still have my F equals to ma from Newton's equation of motion. And net force is going to give me C, right? I have this here minus the whole of this, right? You don't need to add the minus. The minus has been added for you already. Do you understand now? But if you did not add the minus initially, so it will be something like this: T minus into bracket of FR plus M1G sine theta, everything to be equals to MA. Does that make sense? So by the time you open the bracket, you will still end up having minus M1G sine theta equals to MA. So it's still the same, right? But here, I added the negative sign for you to make everything more easier. So I have minus FR minus M1G sine theta equals to MA. So this is my equation 1. But before I go there, that it is my equation 1, I can have my mu r here in place of FR because you know FR is the same thing as mu r, right? If that is the case, what do I have here? G sine theta, everything to be equals to MA. This would be my equation 1. So for the second part of it, equation 2, minus t, right? Let me change that color. So I have minus t plus m2g equals to ma. This is your equation 2. That's all for this case. For case 2b, we have the scenario having a pulley here, right? So upon the pulley is a string holding two masses at each of its ends, something of this nature, right? So if the surface is a rough surface, this place will be rough, right? And because it is rough, expecting coefficient of friction. So assuming your coefficient of friction is between the surface here, so you're having coefficient of friction to be unknown, right? Now, if this is M1 and this is your second mass, M2, provided M2 is greater than M1, so what will happen to acceleration? The body would accelerate this way. But note that the coefficient of friction will be kinetic friction because the body is accelerating. It won't be a static coefficient of friction. Does that make sense? So this is your acceleration, right? So in the string, there must be a tension, and the tension is tending towards the pulley, right? So this body is traveling, the mass is traveling downwards, hence acceleration due to gravity is positive. Here, the body is only sliding on a surface. So in that case, we are not having anything like minus g or positive g for this case. So what's the weight bringing this body down? The weight will be positive g, positive m2g, right? And what's the weight of this body? The weight is actually acting to the center of the earth, right? So the weight is equals to m1g here. The weight is not on the opposite side, right? Because the weight of the body is always acting towards the center of the earth. So the weight here for the other case is actually falling here because the body is elevating, right? So we cannot say that the weight is purely here, that it must act to the center of the earth. Of course, it should, right? But in this case, because the body is on an inclined plane, the weight has been resolved to Fy axis and has also been resolved to X axis, and that's your W cos theta here. Does that make sense? And that will be the one that will be equals to your R. So whenever you need R here, that will be your R. Does that make sense? So you have W cos theta here. And your U here is your UK. That's coefficient of kinetic friction because the body is accelerating. If that is well understood, can we continue this case? So what we have here, since the weight is lying here and the body is moving in this direction, what will happen to friction? Friction would be here, and your frictional force is equals to mu R. Note that for this kind of body, your R exists here. Your R is still equals to M1G. It means that your R is equivalent to W, right? So what other thing do we need to pick out in the system? I think that's all. So for us to solve the acceleration, so you can be asked the acceleration in the system, you can be asked the tension, you can even be asked the frictional force, sometimes the question of kinetic friction. Does that make sense? So how are you going to deal with this? Still the second question of motion. So we have this done. This is your net force. Net force would be, for this scenario here, I'm going to have my tension. Will it be positive or negative? So this tension here will be negative. This tension here must be positive because both tensions cannot be positive. Does that make sense? Hence, your frictional force is negative, right? So tension minus Fr, everything will be equal to Ma. This will be the equation 1. So for the other equation, tension and this. So you have minus T plus M2G, right, equals to MA. So case 3A, looking like a triangle. We have an angle here, theta. We have another angle here, theta. And the pulley lies here. And upon the pulley is your rope, right? So I have here too, the second mass lying here, right? So provided that the surface is frictionless surface, right? And I'm not expecting coefficient of friction, whether coefficient of kinetic or static friction, because the surface is frictionless. But note that no surface is totally smooth. Does that make sense? But since the condition has been given to you that the surface is frictionless, you have to forget about the coefficient of friction, right? But if the coefficient of friction is given and is asked in the question, you should know that the surface is not totally smooth. Let me have my M1 here and M2 here. Provided M1 is greater than M2, what am I expecting? The body would accelerate this way. And don't forget, your tension would be towards the pulley, The tension here too will be towards the pulley, right? So since this is traveling in this direction, what happens to gravity? Gravity becomes positive because it's traveling in favor of gravity. Hence, the weight bringing this object downwards would be m1g is inclined, right? So you have m1g sine theta, right? This is positive, right? So what happens to tension here? Tension is negative. So the weight bringing this down here too would be minus m2g sine theta. So the angle is still sine. Because I don't have frictional force, these are all the forces I'm going to have for this case. So how am I going to solve the question if I'm asked to find the tension or probably I'm asked to find the acceleration, right? I have my F equals to ma. So this is still my net force. For this case here, I have T minus m2g, right, sine theta, which is equals to ma. So this is my equation one. The other equation for this direction, I will have minus T plus m1g sine theta, everything to be equals to ma. Note that your ma here, your m here is m1a, right? For this scenario, here it is m2a because your m you're using here is 2. Let's call this case 3a. So we can have case 3b when it is